Very good morning, friends. Myself, Dr. M.H. Chennaiya. In today's video, we are going to work out a problem on the projection of a square prism whose dimensions are given, and it is being suspended from one of the corners of the top face. Top face will have a square face, and there are four corners A, B, C, D. It is supported from that. And friends, let me tell you about the steps involved in obtaining the projections of this prism when it is suspended from a corner of the top face. Friends, in all the problems, whether it's a problem on prism or a pyramid or a cone, in case of all these, keep the object on HP such that one of the corners of the object will come to your right. So since it is a square prism, I am writing the top view a square of 30 millimeter square. This has got a dimension of 30 millimeter. You can say 30 SQ or simply 30, and obtain the front view. That is the initial position, and the prerequisite is that one corner should be to the right side, whether it is a square prism or a pentagonal or a hexagonal prism or a pyramid also. Now friends, after that, the second step is we have to name the corners of the top and bottom faces, A dash, B dash, C dash, D dash. That's obtained by transferring all these points from the top view to the front view, and we have got this front view, a rectangle with the given height 70 millimeter specified in the problem. Next, what happens, friends? We have to locate the center of gravity of this solid. Friends, remember, for all these solids like prisms, cubes, and the cylinders, for these three, the center of gravity G lies at the mid height. Mid height means what? From the bottom, it is at a height of 70 by 2, that is 35 millimeter, which I call it as G. And in the next step, we are going to join the G to one of the corners of the top face. So I have joined here as line A dash, C dash. So this is the initial position of the solid. Friends, what do we do next? We join C dash to G, the center of gravity. And after locating this line, we are going to redraw this line C dash G such that it is vertical. The length of this C dash G is same as this. And now at this point C, we will have to locate this line C dash A dash. So C dash A dash can be located by making or knowing this angle made by C dash G with A dash C dash. Say it is alpha. I have marked alpha here with respect to this and obtain this A dash C dash. Friends, once you have that, you can obtain these three lines by drawing parallel to this line here. Now this is how the object looks when it is suspended from a point C dash by a small thread, say. Friends, here you should remember, since it is freely suspended, it should not touch. None of the parts of the solid should touch the XY line. Now friends, for this position, which is very important, and remember, this is exactly equal to this first figure. These two are exactly the same. And now let's obtain the top view of these, friends. When I look from the top, this complete top is A, B, C, D, or A dash, B dash, C dash, D dash is available. You get the points one by one. For example, if I want A, write a vertical line from a horizontal line from here. The point where those two intersect is point A. Similarly, C, vertical line from C, horizontal line from C, they meet at this point. Like that, you are going to obtain all the four corners of the top face and join them by straight line. So I am going to join this by straight line. Next, friend. Similar to the top face, you have the bottom face also exactly identical to that. We obtain this A1 dash, B1 dash, D1 dash, etc. and obtain the total top view. And friends, in the top view, when it is suspended from the corner, you are going to have this in which the axis O1, that is O dash, O1 dash in the front view. It appears as a horizontal line parallel to VP. So I'll write down here, axis parallel to VP. It has become parallel now. But as per the question, it says draw its projections when the axis appears normal to VP. The axis appears perpendicular to VP. So friends, again you see here we have this third figure, and the figure you are going to write here will be a photocopy of this. But the condition is that axis O1, which is parallel here, should become vertical. So I will say here axis O1 is appears perpendicular to VP. So friends, this is ABCD, the top face. This is A1, B1, C1, D1, the bottom face. I have redrawn all this such that this is rotated through an angle of 90 degree. So this is the final top view of the prism. Friends, now we have to obtain the corresponding front view. So how do you draw this? Friends, you will consider the faces one by one. Say, I am taking the top face first. In the front view, top face this is this line. So we have to get 4 points on that. How to obtain? Let us start from corner A of the top face. So I written a vertical line from A, horizontal line from A dash. They meet at this point and I mark it as A dash. Similarly, B, vertical line from B, horizontal line from B dash. They meet at this point B dash. So I got A dash, B dash. Similarly, you get on this C dash and B dash here. So you got all the 4 corners of the top face. So A, B, C, D. You are going to have a similar face for the bottom surface also. Remember, all these edges will be parallel to each other. This A dash, B dash parallel to A1 dash, B1 dash, and this D dash, B1 dash parallel to B dash, B1 dash. So you are going to have all these parallel to each other. And friends, you can see when it is suspended from this corner, as you see here, these borders of the figure are completely visible. The vertical edges D dash D1 dash, B dash B1 dash, then A dash A1 dash are visible to the observer completely. C dash C1 is also visible. But the corner A, which is away from the observer, is not visible. Hence, the lines connecting A dash to B dash, A dash to D dash are to be shown by dotted lines indicating that they are not visible. Similarly, here friends, the edge C is also not visible, and hence the connecting lines C1 dash D1 dash, B1 dash C1 dash are shown by the dotted lines. Friends, this is the final front view of the prism. This is the final top view of the prism. So before I close this or complete this video, I would like to just give some important points in it. Friends, the object is a square prism which has got a height 70 and the side is 30. It has to be suspended from one of the corners. As per the general rule, one of the corner of that solid should be to your right side, that is the right side of the observer. Place the object in that way such that all the 4 base edges of the solid make equal inclination of 45 degrees with the VP. In the second step, we are going to locate the center of gravity G of the given prism. And for all the prisms, it is at the mid-height. Mid-height means 70 by 2. So I have marked G here. And then we are going to join one of the corner of the top face to G. Next, we are going to redraw this figure such that this line C dash G becomes vertical or perpendicular to XY. and we mark this angle alpha at this point C dash. This is alpha. On that we are going to have C A dash, then BD will be in the center. You can obtain this line. You know this height perpendicular to that, obtain the bottom face. So this is the bottom face, this is the top face of the square prism. Next friends, if you observe the top view of this top face ABCD, which is square in shape, appears as a rhombus here. Similarly, for the bottom face, you are going to have one more rhombus, and we have completed the top view when it is freely suspended from one of the corners, that is C dash. Next friend, if you observe the top view, the axis O dash O1 dash in the front view appears as a horizontal line O1 in the top view. That is to say that the axis of the prism is parallel to VP. But as per the question, it has to be normal to VP. It has to appear normal to VP. So whatever the figure I have got here, I am going to redraw this figure here as a final top view such that this axis becomes vertical and we obtain the corresponding front view. Friends, you can see here in the front view all the borders of the figure like this are shown full line. The edges DD, edge BB and CC are also full line, and even this part is also full line. But friends, this corner is not visible, that is C1 dash is not visible. Hence I have shown the edges connecting C1 dash with B1 dash, C1 dash with B1 dash by dotted line or invisible line. Friends, this is how we obtain the projections of the square prism when it is freely suspended from a corner of the top face. And you can work out a lot of problems based on this principle, taking different prisms such as square prism, rectangular prism, pentagonal, hexagonal prism, and also a cube. Friends, I hope the presentation was interesting, and please go through the complete video and do not skip anything in between. And if you like this video, do share the information about my video and about my YouTube channel link, namely Engineering Drawing and Machine Design by Dr. MHA, without fail, with all your friends. Thank you for watching my YouTube video. Have a wonderful day. ಇಲ್ಲಿ ಕೂಡ